Did you ever notice that when you program in different languages, you usually solve the problems in different ways? It's amazing how the programming language that we choose for our open source projects can attract different people and even condition the kind of community that will rise from them. Today in Code of Culture, we will talk about linguistics and how open source projects are affected by programming languages. Before getting deep in linguistics and symbolic anthropology, let's see an example from the movie Arrival. In the film, the protagonist, a linguist, learns an alien language that completely changes her perception of time. By the way, I didn't warn you about the spoiler because you should all have seen this movie before. Well, this example illustrates the idea of linguistic determinism. This is an hypothesis in symbolic anthropology that suggests that the language that we use can shape our thoughts and perceptions. This idea was first introduced by the anthropologist and linguist Edward Sapir and his apprentice Benjamin Lee-Whorf. That's why it's known as the Sapir-Whorf hypothesis. But it's about the spoken languages. Can programming languages also change the way we think? Let's consider a simple problem: designing a system to manage a zoo. Here is an example of how the same problem can be approached by people thinking like different programming languages. For example, the Python thinker quickly creates a clean, straightforward solution using classes for each animal species and a simple user interface. They focus on readability and simplicity, making it easy for other zookeepers to understand it and maintain the code. On the other hand, the JavaScript thinker creates a solution that runs in the browser with real-time updates and a cool modern user interface. They use a lot of libraries and frameworks to make the zoo management system as interactive and fancy as possible. The Go thinker's solution focuses on simplicity and performance. They create a minimalistic design with a fast concurrent system that can handle millions of zoo animals simultaneously. The code is easy to read, but it's mostly backend and lacks some of bells and whistles from other solutions. The C thinker designs a highly efficient low-level solution, focusing on performance and direct hardware access to kernel models. This solution adapts different sensor and wireless technologies to monitor in real time the animals and Arduino boards and Linux-based repeaters around the zoo. The result is a high-performance command line zoo management systems, but will require 2 months training and some human sacrifices to the sea gods to maintain it. The Lisp thinker sees the zoo management system as a series of symbolic expressions and embraces the power of recursion and macros to create a highly customizable and extensible solution. If by extend, you mean adding more parentheses. They develop a system where new animal species can be added easily by defining new functions, and the whole system can be adapted to different contexts with minimal effort. The code is elegant, expressive, and powerful, but its parentheses-heavy syntax may be intimidating to other zookeepers that are not familiar with Lisp, almost anyone. There are thinkers that actually zoologists and naturalists. They need to access historical data to find trends and anomalies in the behavior of animals, and they even use external data as weather variables or migration patterns of other wild species. Their solution is not optimized. It can take some minutes to calculate the aggregated data every few hours, but it shows fancy tables, scatter plots, and other visualizations that they use to publish paper in congresses and improve the health of their animals. Well, this isn't a stupid example, but can show us how each thinker approached the zoo management problem from different perspectives from their chosen programming language, resulting in different solutions that emphasize various aspects like simplicity, interactivity, elegance, performance, or low-level control. We have seen how programming languages can affect the way we approach a problem. Now let's see how different languages can influence the communities and the relationship between its member and your open source projects. Before starting, we have to take in account two main factors that will affect the communities around your code. First is how easy or difficult it is to start contributing to a project. There are languages that are easier than others, making the readability and the accessibility for others a pillar of its philosophy, while others are more obscure and need more time to master them. This will make our communities more horizontal or hierarchical. The more complexity, the more technical knowledge will be valued, and the easier and smaller the project, the more looking for consensus. The second factor that will affect our community is how popular and widespread is a language. When the language is not so common, the few projects that use that technology will attract most of the contributors of that programming language, who will stay in the project for the lack of alternatives and solidarity with other programmers. These will create cohesive and collaborative communities. And on the contrary, projects with popular languages can expect many potential casual contributors, but at the same time, more projects competing for them, and thus less commitment and more difficult to find recurrent contributors and new maintainers. Let's see some examples. Python is known for its readability and simplicity. With its clean syntaxes and emphasis on readability, it encourages developers to write clean, concise code. This can lead to better collaboration and easier maintenance of the codebase. Python's approachable nature may also attract a more diverse group of contributors, fostering a more inclusive community around the project. As an open source maintainer, you will likely find that the Python community values readability and simplicity, leading to a more welcoming environment for newcomers. However, the more popular the language is, the less engagement you can expect to find, because there are many other projects to contribute. On the other hand, JavaScript, with its flexibility and ubiquity in the web, allows for rapid development and prototyping. This can lead to a project evolving quickly and adapting to the new requirements or technologies. However, JavaScript's flexibility can also lead to less consistency and more technical depth, as different contributors might approach problems differently or use varying coding styles. For open source maintainers, this might mean investing more time in code reviews, establishing coding standards, and maintaining technical depth. However, the JavaScript community is one of the most horizontal and welcoming ones, and the way npm packages promote small independent projects makes the ecosystem populated with small packages depending on each other and at the same time highly heterogeneous. Let's see Rust. Rust is a programming language designed for performance and safety, with built-in features to prevent common programming errors. Choosing Rust for a project can attract developers who value safety and reliability, leading to a more robust and stable code base. Additionally, Rust focus on safety might attract organizations and companies that require high levels of reliability on their software, such as those in the aerospace or financial industries. As a maintainer, you may find that the Rust community places a strong emphasis on safety, leading to a more rigorous development process and a focus on long-term stability. Go, or Golang, is a programming language that emphasizes simplicity and ease of use. Its minimalistic design and straightforward syntax make it easy to learn and use. Go's focus on simplicity and maintainability can lead to a project with a clean, easy to understand code base. Many CNCF projects like Kubernetes, Prometheus, or Envoy, and others have chosen Go. As an open source maintainer, you might find that the Go community values simplicity and maintainability, which can lead to a more streamlined development process and a focus on long-term maintainability. Let's go with C. C is a programming language that has been around for decades, and is known for its performance and low-level access to computer hardware and kernel-level routines. Choosing C for a project can attract developers who are interested in optimizing performance and working with hardware directly and Linux core developers. However, the C language also requires more careful memory management and a deeper understanding of computer architecture, which can lead to a steeper learning curve for newcomers. As an open source maintainer, you may find that the C community values performance and low-level control, which can result in a more experienced but potentially less diverse group of contributors and more vertical communities based on knowledge and prestige. Additionally, you might need to invest more time in code reviews and mentoring to ensure the codebase remains accessible to developers with varying levels of expertise. Lisp. Ha! Lisp is a programming language with a long history, known for its unique syntax and powerful features, particularly in the areas of artificial intelligence, symbolic computation, and functional programming. Choosing Lisp for a project can attract developers who value expressiveness, elegance, and the ability to create highly customizable and extensible functions. Lisp might seem intimidating to some developers, but it can lead to a highly adaptable system that can be easily extended or modified to fit different contexts. As an open source maintainer, you might find that the Lisp community, while smaller and more specialized, is passionate and knowledgeable about the language strengths and capabilities, which can result in a more flexible and adaptable code base. Additionally, Lisp's niche applications may attract contributors with unique skills and perspectives, fostering a diverse and innovative community around your open source projects. And finally, R. R is a programming language specifically designed for data analysis and visualization, especially for people from medicine, genomics, statistics, or physics. This makes it an excellent choice for open source projects focused on statistical computing, data science, and machine learning. In some ways, R and JavaScript are similar because they are both welcoming communities and have an ecosystem of small and horizontal projects. R has a vast collection of packages and libraries which can greatly simplify data analysis tasks and provide advanced functionality. This can make your open source project more attractive to potential contributors who are already familiar with these tools. And also, the different background of possible contributors can lead to a specialized community that is passionate about using R to solve complex data problems. As we have seen, different programming languages can attract different type of contributors, encourage certain problem-solving approaches, and ultimately shape the evolution of your open source projects. As an open source maintainer, it's important to consider the implications of your choice of programming language of your project's future and the community that forms around it. To wrap up this episode, let's remember that the Sapir-Whorf hypothesis suggests that the language we use can influence how we think and find solutions. By understanding the characteristics of various programming languages and their potential impact on open source projects, we can make more informed decisions and create projects that thrive. The more complex the language, the more vertical will be the community, while the more open to beginners and easy to learn the language, the more horizontal will be the communities, but more diverse in number and small projects. Also, choosing highly adopted languages like JavaScript or Python will attract many possible contributors, while using a niche language like R or Lisp can promote smaller but more collaborative and compromised communities. Thanks for joining us in this episode of Code of Culture about linguistics in the open source. We hope it has given you a new perspective on the power of programming languages in the projects that we create. And whatever language you use, happy coding!